to be checked and checked again, redesigned and improved if need be. The ejection system had to work. The hood blows first. The armaments all had to go through the same meticulous eye for detail, whether it be cannons or rockets. Another important test was to find out what would happen if one of the engines got hit from behind. How much damage would the aircraft sustain? Testing of the ejection seat was carried out using a rocket sled. This sequence shows trials of the Su-25 two-seat trainer, which uses the same K-36 ejection seat as the Su-27. The production Su-27 supersonic all-weather fighter interceptor was finally rolled out in 1984 with an impressive set of credentials. It had a top speed approaching 2,500 kilometers an hour, that's over 1,500 miles an hour. But it was also highly maneuverable at very slow speeds, as this rare Russian film shows. It could climb up to 19,000 meters, that's over 2 miles high. It had a range of 4,000 kilometers, or over 2,000 miles, and it could stay in the air for about 5 hours, with a maximum weapons load of 8 tons. Between 1986 and 1989, a highly modified version, the P-42, challenged the American F-15 specially stripped Streak Eagle for a number of world records. The P-42 was so clean that with its uprated engines it had to be tethered to a military vehicle using twin cables and an electronic lock release, as the standard brakes simply couldn't hold it back. The P-42 set a total of no less than 27 new world records. Its rate of climb was 213 meters or 700 feet per second. The Su-27 had an integral airframe with the wings and fuselage blended together to give it more lift and less drag. With its relatively fuel-efficient Saturn Lyulka turbofans, its aerodynamic airframe and room for more internal fuel, the flanker had exceptional endurance for an aircraft of its type. It had 2 powerful horizontal stabilizers, flaperons, drooped leading edges, and a fly-by-wire system to improve both its performance and maneuverability. The Su-27 was designed to be unstable and run by its computers, but the fly-by-wire system was so efficient that it meant that the pilot controlled the aircraft in exactly the same way as a stable one. The same system controlled the so-called high-lift devices, raising the aircraft's all-important lift-to-drag ratio during a combat maneuver, again being greater at a greater angle of attack. It also made sure that the pilot couldn't overstress the aircraft, whatever he did. This not only protected it from too high angles of attack, but meant that the pilot didn't have to worry about it, which gave him a psychological edge in a war situation. And it also meant that he couldn't get into an unwanted spin or overload the computer system. The fly-by-wire control system had 4 extra channels, so that if any of its components failed, another channel would automatically take over, leaving the pilot free to get on with the job in hand. Viktor Churkin was a combat pilot, So what did he think of the flanker?
The Sujoi Su-27 is very maneuverable, and its minimal radius of turn is quite comparable with that of piston-engine fighters of the World War II. The fighter's good cockpit visibility and small deflections of its control surfaces make possible to pilot it confidently at small altitudes. I always pilot a fighter with pleasure. I find it hard to believe that an aircraft whose weight exceeds 20 tons is so controllable.
Because the Su-27 was designed to land on rough terrain, its engines are protected from any stones or rubble by these simple anti-ingestion protective screens, which work totally automatically during the taxiing, takeoff and landing phases. Its twin engines are set well apart with an integral fire protection system between them. The wide clearances between the fuel tanks and intake ducts stop the risk of any fire spreading. The early versions of the aircraft had their fuel tanks filled with polyurethane foam. This is a dramatic example of a fuel tank filled with foam and shot at by a round of ammunition. The same again, a round of ammunition fired at an unprotected fuel tank. All these protective measures meant that the flanker should survive if it was hit in combat. The engines were designed to be easy to maintain, with jobs like changing the first stage blades of both a compressor and a turbine right on the airfield, without having to send the whole engine to the repair plant. Two search and track systems were coupled to a look-down pulse Doppler radar, an infrared target finder with a laser rangefinder, and a helmet-mounted sight system, which allows the pilot to aim his weapons at the target without turning the aircraft. A navigation system and an automatic flight control system means that the aircraft can take off in bad weather, day or night, with a 200-foot cloud base and 2,500-foot visibility. There are 10 hardpoints under the aircraft for weapons or stores. Early versions carried 4 Archer air-to-air and 6 Alamo missiles. Apart from the underwing stores, Flanker has an internal 30mm cannon with a potent 200 rounds of ammunition. The cannon is linked to the target designator with a rangefinder which is said to help in close combat. With its variety of missiles, the Flanker can fight from a distance or at close quarters. One of